Assalamualaikum warahmatullahi wabarakatuh. My name is Nurin binti Muhammad. The hydrocarbon that we choose is ethylene. Ethylene, a colorless flammable gas, is a key component in chemical industry used in various industrial processes like plastic and polymer. It is produced through steam cracking hydrocarbon in large scale petrochemical plant. Significance of ethylene in the polymer industry. First, polyethylene production. Polyethylene production involves in the polymerization of ethylene, resulting in versatile and widely used plastic with application in packaging, container, pipe, automotive component, and consumer goods. Second, various polymer production. Ethylene is a precursor for other important polymers such as PVC, polystyrene, and ethylene propylene rubber, which have diverse application in construction, automotive, and consumer good industry.
Next, I will give you a short brief on the production process of ethylene. This picture shows the ethylene productions via cracking of ethane and propane. Production process of ethylene involves three main steps, which is the first one, cracking and quenching, the second one is compression and drying, and last one is separation. In the cracking and quenching step, an ethane propane mixture is fed to the furnace, in which, under high severity condition, it is cracked and forming ethylene, propylene, and others byproducts. The second step is the compressions and drying. The compressions of the cracked gas are performed across 5 stages. After the third stage of compressions, carbon dioxide and sulfur are removed from the cracked gas by the caustic soda and water washes in the caustic scrubber. The compressed cracked gas is cooled and subsequently dried by the molecular sievers that remove most of the water. The last step is separations. The dried cracked gas is fed to a cool box for the removals of the hydrogen and light hydrocarbon while minimizing the ethylene losses.
Unique technique of ethylene. First, ethylene-based material and polymer. Ethylene is a key component in the production of polyethylene, a material with unique properties like low density, chemical resistance, a good mechanical strength, making it popular choice in various industries. The polymerization process can produce different types of polymer such as HDPE, LDPE, and LLDPE, which are specific use. Second, ethylene production and synthesis. Ethylene is primarily produced through steam cracking of hydrocarbon like natural gas and naphtha, heating them to break down into a small molecule like ethylene. It can also be produced through pyrolysis of ethane, an environmental friendly method depending on the desired purity and quantity.
This is the chemical structure and reaction of ethylene. Ethylene undergo polymerization reaction and is carried out at a higher pressure and high temperature in the presence of catalyst. Ethylene is a stable molecule with two carbon atoms connected by a double bond. Polyethylene is made by the reaction of multiple ethylene molecules in the presence of catalyst. There are several properties of ethylene that make ethylene used in polymer industry. First, reactivity. Ethylene is highly reactive due to the presence of a double bonds between carbon atoms in its molecular structure. This reactivity allows ethylene to undergo polymerization reactions, forming long chain of repeating ethylene unit. Second, stability. Ethylene is relatively stable, allowing for controlled polymerization process. This stability is important in industrial to ensure consistent and predictable outcomes in the production of polymers. And lastly, polymerization method. Ethylene can undergo low pressure and high pressure polymerization. This method offers flexibility in adapting the properties of the resulting polymers, allowing for the production of various types of plastic with specific characteristics.
Polyethylene can produce products such as plastic bag, bottle and plastic film. Firstly, polyethylene is recyclable. Polyethylene is a thermoplastic, meaning it can be melted and reshaped without undergoing a chemical change. This characteristic allows it to be recycled multiple times without a significant loss in its mechanical properties.
Next, polyethylene is non-biodegradable because polyethylene has a long chain of carbon and hydrogen atoms, forming a hydrophobic structure and make it resistant to the enzymatic actions of microorganisms that typically breaks down organic material during the natural biodegradation process. Other than that, polyethylene has a higher molecular weight that consists of very long chain of repeating units. The size of the chains make it difficult for microorganisms to break down into smaller, hence it cannot be decomposed.
Ethylene is the world's most important chemical. Ethylene is a key building block in plastic and crucial in the manufacturing industry around the globe. According to the Director Refining and Chemicals, Flow Control Business Line, Company of Valmet, there are several critical problems in ethylene production. Firstly is meeting growing demand. He states that ethylene is the largest and most versatile building block in the petrochemical industry. Ethylene production alone is expected to reach a market size of $287 billion by 2030. This suggests that petrochemical production will also ramp up to meet this demand. Secondly is critical valve in the ethylene plant. Due to the extreme temperature and pressure in ethylene production, equipment like valve must withstand a volatile environment and perform efficiently. Braking is a critical step and extreme caution that is exerted to protect equipment from harsh conditions or such thing as sudden back pressure drop. The various valve cracker unit valve selection play a critical role in maximizing quality ethylene output. Several valves are involved in obtaining the suitable input ratio of inputs. Demand for ethylene has steadily risen and so has the need for valve solutions that offer maximum reliability, safety and performance. There are many critical valves within an ethylene plant. From cracking to purging, valves are subject to a wide range of thermal conditions, corrosive medium and cold residue. In this demanding application, inferior valves will quickly wear, leak and need service.
As the conclusions, I would like to highlight three main key points of ethylene. The first one is in terms of chemical compound. Ethylene is an unsaturated hydrocarbon and it is a fundamental building block in the petrochemicals industries. The second one is applications of ethylene. Ethylene is used in the manufactures of polyethylene, a widely used plastic, and plays a vital role in the productions of PVC, ethylene glycols, and also other chemicals. And the last one is feedstock. Ethylene can be derived from various feedstock, including natural gas, crude oil, and other hydrocarbons. There are three potential future developments for ethylene. The first one is advanced processing technique. The 3D printing or advanced molding techniques lead to the new applications and the improved performance for ethylene-based product. The second one is a biodegradable polymer. Incorporating bio-based feedstock or additive that allows the material to break down readily in the environment. And the last one is circular economy initiative. Effort to establish a circular economy for plastic may influence the ethylene's future development. This could involve the recycling and the reuse of ethylene-based products, reducing the reliance on traditional linear production model. Ethylene are expected to show high trending in the forecast period, as shown in the diagram below.